Problem 8. A long straight rod has a radius of 5.5 centimeters and a charge per unit length of 20.5 nanocoulombs per meter. Find the electric field at the following distances from the axis of the rod, where distances are measured perpendicular to the rod's axis. All right, so the key parts here is long, which means infinite. Ooh, that is an unusually straight line. Nice, well done, good for me. And metal, started off well, but petered off, which means conductor. Yep, and then I guess rod is important too. Yep, and all the straightness left. All right, so it has a radius of 5.5, so if we're measuring at 1.5 centimeters, that's going to be inside the conductor. I'm going to start by writing up the formula that we already know. E equals, make this bigger, what's it, 2k lambda over h. I can write it, especially since it's such an important formula for this. 2k, little k, lambda, is that lambda? I'm going to say it's lambda, over h. So the idea here is the electric field would be 2 times the k, constant we know, times the, it can't be lambda, is that lambda? That's just a terrible lambda. Yeah, I'm going to say it's lambda. Over h, which h is the distance away from the rod. So we already derived that in a previous video. If you want to see it, click right there, and I'll bring you back to the video and we'll walk through where this formula comes from. But you should kind of, I don't know if you'll be given this formula, but if you're not, you should have it memorized, at least for this exam. All right, so back to where I was saying. So when you're inside a conductor, there is no electric field, which is not entirely true. There are electric fields inside of conductor, but the net electric field will be 0. The electric fields will be situated to cancel themselves out. The electrons within the conductor will orient themselves so that the net electric field is 0. And then therefore there'll be no direction. All right, 15. 15 is bigger than 5. Therefore, electric field. Okay, so we can do this. So, all right, I'm going to first convert this guy to meters. Draw a little dot right there, get rid of that dot, and get rid of the C. Bam, 0.15 meters. So professional, so professional. All right, and I'm going to go straight for the formula. Yep. So 2 times, all right, 8.99 times 10 to the 9th. 8.99 times 10 to the 9th times 20.5 times 20.5 times 10 to the negative 9th. Yep, I probably could have just left off the 10 to the 9th and 10 to the negative 9th per meter. And now we are 0.15 away, divided by 0.15. Actually, the inefficiency here is kind of bothering me. Now let's see if we get the same answer, 2457, and it is 2457. Huzzah. Okay, magnitude 2457 newtons per coulomb. 2, 4, 5, and 7. I should have drawn a picture first. I didn't draw a picture. I'm going to draw a picture. Here's the rod. Oh my gosh, so terrible, so terrible. Yeah, I'll use a square, or I guess rectangle. And we're going to make it outline, and we're going to use black. All right, there we go. So here's the rod. Here's our 15 centimeters. Oh, that'll be H. That H is a little excessively bad. H. There we go. And now we're going to do the same thing, but for 150 centimeters, which will be 1.5 meters. So all I'm going to do is I'm going to go back to the exact same formula I just used, change 0.15 to 150, and we have 245, which makes sense because we're dividing by the distance. And we divide by a distance that's twice as much, we're going to get an answer, or by a distance that's 10 times as much, we're going to get an answer that's 1/10. So n is further away, which makes sense too. Oh, I was trying to find direction. All right, so it's 20.5 nanocoulombs, but specifically it's positive. Therefore, the field will start from the positive charges, which are in the rod, and go outward. So it's going to be radially outward. Outward. Oh my gosh, that is so terrible. Terribly tragic. Oh, paste, bam. I'm glad that my handwriting does not matter for this portion. Yep, and don't know where you came from, but you should go away. All right. Excellent. That's all there is to this problem. So again, if you want the derivation for the metal rod, click the link that I showed you earlier, or just look down in the description. I'll have a link there as well. And yep, that's the formula that you should memorize in life. All right, well, at least memorize for the next few months. All right, take care. See you on number 9.